We have already gone over cases in which include positive numerators or negative numerators. But what about when you have a numerator that is 0? 0 is neither positive nor negative, so this would be a separate case. For this case, I plan to go over 3 examples. For each example, I plan to explain why you add fractions in a certain way, both by using a model and without using a model. Here is our first example. First of all, we're going to need to get 0/8. If we get 0/8, we get no 8s, and therefore we do not get anything. The next step is to get 5/8. Let's go and quickly do that right now. Let's now figure out what the total is to figure out what 0/8 plus 5/8 is. 1/8, 2/8, 3/8, 4/8, 5/8. Therefore, 0/8 plus 5/8 is equal to 5/8. This makes sense because we got nothing when we got 0/8. And then we got 5/8. If you get nothing and then get something, your total will be that something. I will now like to show that this rule of adding fractions, that you add the numerators but keep the denominators the same, works also when you have a numerator of 0. Suppose that I wanted to solve 0 plus 5. Well, first of all, I would get no pom-poms. I would get 0 pom-poms. Next, I would get 5 pom-poms. 1 pom-pom, 2 pom-poms, 3 pom-poms, 4 pom-poms, and 5 pom-poms. To figure out what 0 plus 5 is, I figure out what the total is. And the total is 1, 2, 3, 4, 5. Therefore, 0 plus 5 is equal to 5. This seems a lot similar to the example we just did. The only difference is that in the example we just did, everything was in 8s. Therefore, to add 2 fractions, even if you have a numerator of 0, you add the numerators but keep the denominators the same. I would now like to show how we can know that the rule for adding fractions does not change even if one of the numerators is 0. Right now, I would like to show that 0/8 plus 5/8 is equal to 0 plus 5 over 8. On the left side, I exchange the 0/8 for 0. Why can I do that? Well, 0 divided by 8 is equal to 0. How do I know that? I plan to explain in the next set of videos why behind for certain rules that involve 0. And then on the right side of this equation, I exchange the 0 plus 5 for 5. How do I know that 0 plus 5 is equal to 5? Well, I explained in a previous set of videos, linked in the description of this video, that 0 plus anything is equal to that anything, which would mean that 0 plus 5 is equal to 5. We still do not know that this equation is true. And then I substitute the 0 plus 5/8 for 5/8. Why can I do that? Well, 0 plus anything is equal to that anything, and that anything could be 5/8 as well. And now we do know this is true. We do know that 5/8 is equal to 5/8. Because we know the last line is true, we know the middle line is true, and that the first line is true. That the rules for adding fractions does not change even if one of the numerators is 0. Our next example is -2/7 plus 0/7. So first of all, I'm going to need to get -2/7. -1/7, -2/7. I would like to note that in this case, red represents negative. And then we get 0 sevenths. We get no sevenths. We're getting nothing. We're not getting anything. So let's just go and get nothing. And there you go. To figure out what negative 2 sevenths plus 0 sevenths is, I simply figure out what the total is. And the total is negative 1 seventh and negative 2 sevenths. So negative 2 sevenths plus 0 sevenths is equal to negative 2 sevenths. This makes sense because I'm getting something and then I'm getting nothing. So I'm left with that original something because that nothing, that 0 sevenths, does not do anything. I would now like to show that the rules for adding fractions does not change even if one of the numerators is 0. Suppose that I wanted to solve negative 2 plus 0. If I were to solve this by using counters, first of all, I would get negative 2, negative 1, negative 2. And in this case, red represents negative. Then I would get 0. I would get nothing. So I'm not really getting anything. So let me just get nothing. To figure out what negative 2 plus 0 is, I simply figure out what the total is. And the total is negative 1, negative 2. Therefore, negative 2 plus 0 is equal to negative 2. This may seem similar, very similar to the example we just did. The only difference is that in the example we just did, everything was over 7. Everything was in sevenths. Therefore, to add two fractions, even if one of the numerators is 0, you simply add the numerators but keep the denominators the same. I would now like to show, without using a model, that the rules for adding fractions, that you add the numerators but keep the denominators the same, still applies even if one of the numerators is 0. For this example, I would like to show that negative 2 sevenths plus 0 sevenths is equal to negative 2 plus 0 over 7. First of all, I'm going to exchange the 0 sevenths for 0. How do I know that 0 sevenths is equal to 0? Well, I know that 0 divided by 7 is equal to 0. In a future set of videos, I plan to explain the why behind for some rules involving 0. When I create that future set of videos, I plan to link it in the description of this video. On the right side, I exchanged the negative 2 plus 0 for negative 2. How do I know that negative 2 plus 0 is equal to negative 2? Well, I know that anything plus 0 is equal to that anything. I explained why in a previous video, and the link for that video is in the description of this video. So we still do not know that the middle line is true. But now I can exchange the negative 2 sevenths plus 0 for negative 2 sevenths. Why can I do this? Well, I know that anything plus 0 is equal to that anything. And now finally, we do know this is true. We do know that negative 2 sevenths is equal to negative 2 sevenths. Because we know the last line is true, we know the middle line is true, and that the first line is true. That the rules for adding fractions does not change even if one of the numerators is 0. Our next example for when you include a numerator of 0 has two 0 numerators. So first of all, let's get 0 twelfths. We're getting no twelfths. We're not getting anything. So let me go ahead and just get nothing. And here we go. I just got nothing. Then we're going to need to get 0 twelfths more. We're getting no twelfths more. We're getting nothing. We're not getting anything. So let me go ahead and just get nothing more. And there we go. And what we're left with? No twelfths. 0 twelfths. Therefore, 0 twelfths plus 0 twelfths is equal to 0 twelfths. I would like to show that even if you have two numerators of 0, the rules for adding fractions does not change. You still add the numerators and keep the denominators the same. Suppose that I wanted to solve 0 plus 0. So first of all, I would get 0. I would get nothing. And here you go, I got nothing. Then I would get 0 more. I would get nothing more. And here you go, I got nothing more. I got 0 more. And what is the total? I have nothing. I have no pom-poms. So therefore 0 plus 0 is equal to 0. You may notice this is very similar to the example we just did. The only difference was in the problem we just did, everything was in 12s. Therefore, to add two fractions, you add the numerators but keep the denominators the same. I would now like to show, without using a model, that even if both numerators are 0, you still add fractions in the same way. You still add the numerators and keep the denominators the same. For this example, I would like to show why 0 12ths plus 0 12ths is equal to 0 plus 0 over 12. On the left side, I exchanged the 0 12ths for 0. How do I know that 0 12ths is equal to 0? Well, I know that 0 divided by 12 is equal to 0. In the next set of videos, I plan to go over common rules that involve 0 and to explain the why behind. On the right side, I exchanged a 0 plus 0 for 0. Anything plus 0 is that anything, and therefore 0 plus 0 is equal to 0. We still do not know that this is true yet. And then on the left side, I used again the rule that 0 plus 0 is equal to 0. On the right side, I again use the equality that 0 12ths is equal to 0. And yes, we do know that 0 is equal to 0. And so we know the middle line is true, and that the first line is true. That even if you have both numerators of 0, you still add fractions in the same way. Add the numerators, keep the denominators the same. We have already gone over cases that have a positive denominator or a negative denominator. But what about when you have a denominator of 0? Because 0 is neither positive nor negative, this would be a separate case. It works out that you cannot divide by 0. I plan to later explain why in a future set of videos that should cover common rules that involve 0. When I create that future set of videos, I plan to link it in the description of this video. Because you can't divide by 0, you can't have a fraction with a denominator of 0. Therefore, you cannot add fractions with a denominator of 0. So for this case, the rule is not to add the numerators and keep the denominators the same. The rule is you can't do it in the first place. The next video in this set of videos is parts 10a and 10b, which is the first part of explaining why you add fractions in a certain way by using a number line. If you wish, please click on the link here below.